એવું હોય તો તમારું માઇક થોડુંક મ્યુટ કરી દેજો ને બાજુ ટીવી ની કોઈ નહીં
35. So all infertility specialists and people working in the fertility segment will agree to it that the most important factor in fertility management is the age. Like if you have age on your side, the chances of result are better.
Hello. Good morning, everyone. So, my name is Dharmesh Mistry and I am from Stack Industry. Okay, so today our topic is cloud-based predictive and preventive maintenance. So, in this, we will go through various techniques where we can monitor the data over the cloud for various things like temperature, pressure, vibration, and everything. So, we will start. So, what we exactly do? So, we are manufacturers and suppliers of various types of sensors, which includes small sensors from proximity sensors, photoelectric sensors, pressure sensors, moisture analyzers. So these are all the different types of sensors for measuring different things in the industry. Okay, for example, say moisture analyzer. So moisture analyzer is an instrument which is used to measure the moisture in a conveyor belt for cement industry, for steel industry to measure the moisture in coke. So there are different types of sensor depending on different types of application. Okay, so we have safety light curtains which are used for safety purpose, flow sensors for flow measurement of air and flow measurement of water and various chemicals. We have different wireless and IoT devices which are used to monitor the data of these all sensors on the web server, on mobile app, and various and for doing various other analysis. We also have different distance measurement sensors, 2D 3D profiling. So these are all the different types of solution we are giving in industries. All these sensors are bound to give data to the PLC and other things only. So according to our today's topic or cloud based monitoring, we will show you how these all sensors can be connected to the server and we can see the data. Okay, so what is industrial revolution? Like in this topic we will cover regarding industry 1.0 to industry 4.0. Here you can see it's the first industrial revolution started in somewhere around 1784, where all the works means something production started. Like for example, we can say that building a motor or building a locomotive, steam engine, this all thing started in industry 1.0. The revolution was around say 100 years. So where in industry 1.0, the first thing was to generate the power using the steam. The best example for that is the steam engine. Okay, in second revolution, means around after 100 year, when the electricity and everything was generated, at that time it can be told that it was industry 2.0, where the Ford and everyone started the assembly lines to manufacture the cars. So here a little bit of automation came down, where the people started assembly line and to and to produce the product in mass. For example, means for the best example is the cars. So the Ford company have started the assembly lines to start the production of their car. Then third revolution came around in 1969, where the microcontrollers were developed. Then PLCs were developed and computers were used to automate these lines. So this was like industry 3.0, which ended recently just few years back. In industry 3.0, the, uh, the machines came, the robotics came into picture. So all the production was automated, where mostly all the humans dependencies were decreased. And now there is a fourth revolution which is known as industry 4.0. So in industry 4.0, all the machines which were used in industry 3.0 like PLC, SCADA, HMI, this everything is connected to internet. And the basic thing for this is, after connecting it to internet and after collecting all the data, okay, this data is collected, and artificial intelligence and deep learning is used to predict the future maintenance days, to predict whether the machine is going to shut down in few days or not, and to predict various other data and to save the data on the cloud server. Means here the cloud server is used to collect the data and to analyze the data and to know what is, say for example, if we say for production, if we want to check the production of today, okay, we don't need to go to plant, we just have to log into our id even with the iot devices, and we can see what is the production rate. For example, say we want to check the rpm of a specific motor staying somewhere else, so that can be done easily using iot devices. Okay, another example I can tell you, like nowadays we are having internet cars, like mg hector have already deployed their this thing, mercedes is having this thing, bmw is having this thing. So using these things, what we can do, we can switch on and switch off our car, we can check the temperature of our car, we can even check what is the problem in the motor, is there any problem in the batteries, everything we can check. We can directly communicate to our car. That is the type of, say, industry 4.0. Like in any industries, the owner or the manager does not needs to go into industry and check each and everything. Okay, they get all the data in the app, where they can see, means what is going on in the industry, or they might also have a maintenance schedule using the data which have been collected. Okay, so here on right side you have seen, you are seeing the degree of complexity in these things. So as we are going towards industrial revolution with iot and everything, the complexity is increasing day by day. For example, if we say that in first revolution there was very less like data backup and everything, so and you don't need that expertise to run a plant. So at that time the complexity was very less, but now for a iot based revolution, you need knowledge how to maintain, how to go through it, and here you have many chances of good production and good quality. Okay, so these are four industrial revolutions which have already been carried out, and right now we are in the phase of industry 4.0, where everything is connected to a server on data, and all the data are on cloud, and anyone can, means anyone, not anyone, but the person who is given access and authority to manage it, he can manage and see the data, he can track the data, he can analyze the data. There are many tools available and many softwares available to analyze what is going on and what will be the predictive. So in predictive basically means an artificial intelligence, or it can be said as the analysis of data for reducing the downtime of a plant. Okay, so these are the basic four difference from industry 1.0 to industry 4.0. So now we are like, for example, if we want to get some data, so what all data we can get from machines. Okay, so this all data are given to the server by various sensors. Okay, so this all sensors are communicated with a plc or a scada, hmi, or a computer, and this the data, like for example temperature sensor will give the temperature data of the machine. For example, if we take a motor, okay, so motor is vibrating due to some wear and tear, it will vibrate, the temperature will increase. Okay, so this all data are collected by different sensors. Like temperature sensors will collect the data of temperature. Pressure sensors, say there is any chemical line in the production plant, okay, so that line we have to maintain some pressure, say 250 bars or 350 bars. Okay, in extrusion line the pressure range will be up to 250 bars. Then for example level sensors, if there are silos in plant which stores the chemical or raw material in silos, we need to know the level, that how many days this raw material will work. So there we need level sensors. So there are different type of level sensors. This ultrasonic sensor is there, which is used for measuring the height up to say 10 meters. Then we have radar sensors. Radar sensors are used to measure the height up to 86 to 900 meters. Okay, so there are different meters, like flow sensors and flow meters are used to know that what is the flow in the line. Okay, then we have distance measurement sensor. For example, in a tire building company, example C8 tires and Apollo tires, they have to maintain the thickness of tires in quenching process. So what they do, they go on building on the tire. They make a tube first, where they have to maintain the diameter of that tube. So the diameter is maintained by using, say, distance measurement sensors. Then we have profile measurement sensors, vibration sensors. Like vibration sensors are used in various motors. So basically, vibration sensors and temperature sensors are mostly used for motor maintenance. Okay, so to know the health of motors, bearings, gearboxes. So this all sensors are basically used for preventive maintenance in industries. Okay, so basically there are two types of sensors. The first one is the digital sensor and second one is the analog sensor. The function of the digital sensors is just to give output on or output off. Okay, here I have written some names like proximity sensors. Proximity sensors are used to check whether there is metal in front of the sensor or not. For example, if some to measure the RPM. Okay, for example, one flywheel is rotating at, say, speed of 100 rotation per minute. So what a proximity sensor will do? Proximity sensor will sense the rotation. On every rotation, it will give a pulse to PLC, and in PLC we can program to get the RPM. Likewise, same photoelectric sensors are used. Then eye mark sensors. You might have seen on the pouch of Maggie or biscuits, there is black eye mark in the corner. Okay, so that eye mark is used to seal the packet. For example, there are all rolls. There are like bundles of pouches. The pouch comes, the Maggie or the biscuit goes inside, and it is sealed. Okay, so we physically can see that it has to be sealed now, but some data is to be given to machine that when we have to seal that pouch. So that pouch is sealed using an eye mark sensor, where the eye mark is detected by a color sensor, and the output is given. Like whenever the eye marks come, one digital on output is given to the PLC. So what PLC will do, it will seal the packet and it will cut the packet. Okay, so likewise, switches and buttons like emergency switches are used. For example, if there is some emergency, some accident, or some machine is going in wrong way, then emergency switch is pushed by the worker, which immediately stops the machine. Like same like safety light curtains. Safety light curtains are used to stop the machine when means for the safety of human. For example, if a robot is working, okay, and if any human unknowingly inserts the hand in the range of that robot,